start the counter from the PIC3 device. Let me click on power on. See that the counter has started. So it will start from 0 and it is going up. It will go up to 9999. Then it will go over again from 0. So guys, you can see that it is now at 1400, 1500, 1600. This is basically called multiplexing technique of displaying a data on the 7-segment display. Basically, it is being updated sequentially, but it is working at such a fast speed that our human eye thinks that, or it gets dolled in such a way that it sees that they are being updated like in parallel, but in reality they are being updated sequentially, one by one, but at a very high speed. So this technique is basically the multiplexing technique of displaying data on a 7-segment display. So you can see that we had gone to 5500, 5600. Once it reached 9999, then it will start all over again, like it will go back to 0. Instead of going some rag back values, it will go back to 0. So let's see what happens. It's now 7100, 73, 74, 75, 6, 7, 8, 9, 80, 81, 2, 3, 4, 5, 6, 7, 8, 9, 90, 1, 2, 3. See, now it has started all over again. So this is how this is gonna work. Hello guys, welcome to learning microcontrollers. In this video, I'm gonna show you how you can interface a 4-digit 7-segment cathode type display with a PIC16F877A microcontroller to run a counter from 0 to 9999. So guys, this is the 4-digit 7-segment display I'm talking about. You can see that it has 6 pins at the bottom. At this side, it also has 6 pins at the other side as well. You cannot see it. From the top, it looks like this. Then guys, I told you earlier, it has total of 12 pins at the back, 6 at the top back and 6 at the bottom back. Now the pin at the top back left side is the digit 1 pin. Then we have A segment, F segment, digit 3 pin, digit 2 pin, and then the B segment. Then at the bottom left side, you have E segment, then you have D dot, C segment, G segment, and finally the digit 4 pin like this. So we have total of 12 pins. Now this digit is the D1 digit corresponding to this pin. In case of a 7-segment cathode, whenever this digit 1 is connected to either to the ground or a 0 is sent from the microcontroller, this digit will get enabled. And in case of an anode type 7-segment, whenever this digit 1 pin is connected to the 5-volt supply or a 1 from the microcontroller is being sent, then this digit gets enabled. But in our case, we are using a 7-segment cathode type. So we have to send a 0 from the microcontroller to the digit pin to enable the digit. Similarly, for the digit 2, we have this pin D2 corresponding to this digit, then D3 corresponding to this digit, and D4 corresponding to this digit. Now guys, the next thing is we have our PIC16F877A microcontroller having 40 pins. It's a DIP version. Then we have this 7-segment from the top view again. So I am gonna label it again for you. At the top left at the back, we have digit 1 pin, then A pin, F, digit 2, digit 3, and B pin. Now at the bottom left, we have E pin, D pin, dot pin, C pin, G pin, and finally the digit 4 pin. As you can see, the 8 pins here are for the 7-segment, while the rest of the 4 pins are for the digit enable. Now guys, for the 8 pins of the 7-segment, we are gonna need 8 220 ohm resistors to connect them with a PIC. So let me show you. This is the digit 1 corresponding to this pin, digit 2 corresponding to this pin, digit 3 corresponding to this pin, and finally the digit 4 corresponding to this pin. Now these are the 8 220 ohm resistor we will need for the 7-segment. So guys, you can use any resistor from 100 to 300 value. The higher the value, the lower will be the brightness of the 7-segment display. But the ideal resistor is a 220 ohm. So I suggest you use a 220 ohm resistor as well. So guys, for the A pin, I will connect it to the one end of the 220 ohm resistor like this. From the other end of the 220 ohm resistor, I am going to send it to the pin number B0 like this. Now I am using the port B for this. You can use any port having 8 pins at least. Port C also has 8 LEDs. 8 pins. Port D also has 8 pins. So any port having 8 pins can be used here. Now here 0 corresponds to A. Now for the B pin, I will connect it to the one end of the 220 ohm resistor. Then from the other end of the 220 ohm resistor, I am going to send it to the pin number B1 like this. Then guys, for the C pin, I will connect it to the one end of the 220 ohm resistor. Then from the other end of the 220 ohm resistor, I am going to send it to the pin B2 of the PIC like this. Then for the D pin, I will connect it to the one end of the 220 ohm resistor. Then from the other end of the 220 ohm resistor, I am going to send it to the pin number B3 like this. And then guys, for the E pin, I will connect it to the one end of the 220 ohm resistor like this. Then from the other end of the 220 ohm resistor, I am going to send it to the pin number B4 like this. Now guys, for the F pin, I will connect it to the one end of the 220 ohm resistor like this. Then from the other end of the 220 ohm resistor, I am going to send it to the pin number B5 like this. Now guys, for the G pin, I will connect it to the one end of the 220 ohm resistor like this. Then from the other end of the 220 ohm resistor, I am going to connect it to the pin number B6 like this. Now guys, for the dot pin, I will connect it to the one end of the 220 ohm resistor like this. Now from the other end of the 220 ohm resistor, I will connect it to the pin number B7 like this. Now you can see that 0 here correspond to A, 1 to B, 2 to C, 3 to D, and so on. If you use a port D, then remember that B can be replaced by D, but 0 will always be A, 1 will be B, 2 will be C. Else you will not be able to use the MikroC 7 segment editor tool. If you want to use that tool, then you have to follow this sequence for 0A, 1B, 2C, 3D, etc. Now guys, our 7 segment LEDs are connected. Let's connect the digit pins. For the digit pins, as you know, D4 is a unit digit, D3 is the 10th digit, D2 is a 100 digit, and D1 is the 1000 digit. Now let's connect the pins. For the D1, I am going to use the pin number D0. You can use any available digital input output pin of your PIC for this, for the digit pins, and you do not need a resistor for the digit pin at all. Now guys, for the digit 1, I will connect it to the pin number D0, that is pin number 19 of the PIC16F877A. For the digit 2, I am going to use the pin number 20 of the PIC16F877A, that is D1. Now for the pin digit 3, I am going to connect it to the pin number D2 of the PIC, that is pin number 21. And for the digit 4, I am going to connect it to the pin number D3 of the PIC, that is pin number 22 of the PIC16F877A. In this way, our digits are connected as well. Now guys, as told you earlier, the D4 digit connected to the pin number D3 is our unit digit. Now the 10th digit is the digit that is D3 connected to the pin number D2 of the PIC. Now the 100 digit is connected to the pin number D1 of the PIC, and our 1000 digit, that is the digit 1, is connected to the pin number D0, pin number 19 of the PIC. In this way, unit, 10, 100, 1000, we are going to go a counter from 0 to 4 times 9, 9999. That will be our maximum value. So in that case, we will need all 4 digits. So let's, before we get to the programming, let me introduce you to the hardware. So guys, this is the hardware we have here. This is a 7 segment display. I am just using this translucent plastic case in front of the 7 digit only because it's too bright, so camera will not be able to catch the digits whatever they are displayed. They will stutter. So to save that, I am going to use it. Now this is our PIC16F877A microcontroller having 40 pins. It's a DIP version. That is our PIC at 3.5. Rest is just the board. So we are only gonna go with this 7 segment display in this video. So guys, let's get to our MikroC for PIC. This is a MikroC for PIC. Let me go to the start page and zoom in. So as you can see, it's version 7.2.0. You can upgrade to 7.5.0 as well. It is also available. Click on new project. This window pops up, new project wizard. Click on next. Write the name of the project, whatever the project name is. 0 2 9999 7 segment tutorial learning microcontrollers. This is the name of the project I wrote. You can write any name you want. Select the place where you want to store the code. Select the microcontroller. I'm going to use a PIC16F877A and select the crystal you are using. I'm using a 20 MHz crystal. Click on next and finish. Then guys, this window will pop up. Before you do anything, first of all, press Ctrl S to save your work. Now the work is saved. Now the next thing is, we will first of all initialize the 7 segment pin, that is at port B. So we write tris B equals to 0 cross 0 0, declaring the port B as output. Now the initial state of the port B, all the LEDs must be 0, like off. So initially all the LEDs are off like this. So in case of an Arduino, you write like pin mode output. So here you use a tris register, and in Arduino you write the command digital high low, digital right high or low. So in case of a PIC, you write either 0 or 1. 0 means low, 1 means high. So So initially all the LEDs must be off. Now we give some initialization delay. 20 milliseconds will do fine. Now guys, for the digit pins, we have digit pins on the port D. I write press D equals to, I will send the digits in binary form now, 1 2 3 4 5 6 7 8. So these 8 digits mean that there are total 8 pins in port D. This is our pin number D0 starting from the right, D1, D2, D3 and up to D7. As told you earlier, 0 means the pin is an output pin. So 1, 2, 3, 4, 5, 6, 7, 8. So 8 bits are being sent as 0. It means all the 8 pins starting from D0 up to D7 have been declared as output. Now guys, the initial state of the port D must be like, we copy this in the binary like this. Now we have our 7 segment cathode, 4 digits connected to the first 4 pin D0, D1, D2 and D3 respectively, meaning that D1, digit 1, digit 2, digit 3 and digit 4 respectively are connected to this pin. So 1, 2, 3, 4. Now as told you earlier, in case of cathode, 1 means disable. If you want to enable the digit, you have to give it a 0. So initially 1 is being sent, because initially if we sent a 1, it means that by default the cathodes must be disabled. So if we give a 0 here, it means it is enabled already. So we cannot do the multiplexing. We are basically gonna do the multiplexing one by one, displaying the digit at a very high speed in such a way that when we see from our naked eye, it will look like that it is on, but in reality it is on sequentially. Digit is being updated one by one. So we will only enable that digit on which the data is to be displayed, and by default all the 4 digits are off. In case of a cathode, if we send a 0, only then the digit will be enabled. 1 means it's disabled. Now we give some initialization delay. This is the initialization delay here. Now guys, we have our digit pins initialized, we have our 7 segment initialized. Now we make an array where we will initialize the values we are going to send to the 7 segment, that is from 0 to 9. The values we are going to use on the 7 segment is only from 0 to 9, but on 4 digits. So we take an array of integers, display 10 digits. 0 to 9 means total of 10 digits, equals to, declare an array. Now display 10, 0 to 9. Now to make a 0 here, first of all, now that is why I told you that you have to follow a scheme here, that you have to make sure that 0 means A, 1 means B, 2 means C, D, etc. So you have to follow the scheme. So you can use this tool now I am gonna use here. Now you go to the tools here. Here you have this. Go down, 7 segment editor. Click on it like this. Let me bring this near because it don't works when zoomed in. So zoom out. Make a 1 here. Click on the segment to turn it on. Just make a 1 here. Now this is our 1, and at 1 it is showing common cathode value 48 in decimal. You copy this and you place it here. Now this is our 0. When we will send port B equals to 48, this means that a 0 is displayed. Now display and the array digit is 0. It means that still the 48 will be displayed. So display 0 means a 0 on the 7 segment. Now make it for a 1. Sorry, it's for a 1. Now make it for a 0. For the 0 it is 63. Now you place it before the 1 like this. Now display 0 means a 0 is displayed. Display 1 means this is 1. Now we make it for the 2. For the 2 it will be like this. It will be 91. So this means that display 0 means 0, display 1 means 1, display 2 means a 2 will be displayed. Now similarly go for 3 and up to 9. Now this is the 3, 79. Now make it for a 4. Now this is the 4. Now make it for a 5. Now this is the 5. Now make it for a 6. This is the 6, 125. Now make it for a 7. Now this is the 7. Now make it for the 8. Now this is the 8. Now make it for the 9. Finally the 9. Now this is our 9. So 111. So in this way, our all the 7 segments values, like in case we declare initialize an LCD, now this will initialize the 7 segment completely. Now display 0 means a 0 will be displayed, display 3 means a 3 will be displayed, and 9 means display 9 means this 9 will be displayed. So that's all. Now guys, we go for our forever loop. Write down while 1 like this, and we will also need a counter. So for that we initialize a counter here, int counter like this, and initially the counter value is 0. So in the one time loop make it 0. So whenever the code runs, it starts from 0. Now guys, first of all we display the unit digit. This counter, whatever the values in the counter must be displayed. So for that we take the initial state of this port D like this, and then we enable the unit digit. So D3, digit 3 is at port D3 we have digit 4, and digit 4 is the unit digit. So we enabled it. I had sent a 0, it means the digit 4 is now enabled. Now we display here port B equals to display is this variable, and for the unit digit, to display a unit digit we have to take the counter, because we want to display the unit digit of the counter, percentage of 10. This is a symbol of mode. Now why this symbol here? Let me show you. We are using this symbol here. See that here on the 7th segment you have 4 digits, 1, 2, 3, 4. This is digit, unit, 10, 100, 1000. Okay. Now whenever the unit value will get to 0 to 9, the control has to be transferred to the next digit. So that's why we use the mode symbol. It is basically a remainder symbol. So when we use a remainder symbol, the remainder will be taken and the value will be transferred to the next digit. So 0 to 9, the value will be transferred to this digit, and when this digit gets to 100, the value has to be transferred to the 100 digit now. It reaches 99. Now whenever the 100 comes, then the mode operator will come into play. This will take the remainder and the value will be transferred to the next digit. So in short, this remainder symbol allows you to transfer the value to the next digit. So this is for the unit digit. Now we had displayed the value, we give some initialization delay. This delay is very important. Lower the delay, the more smoother will be your display, but don't make it that small that you might not be able to see anything. So give just a delay of 25. We will play with this delay. Also I will give you this code programming files, all the MikroC files in my Google Drive link in the description of this video. So you just download and play with this code, you will like it. Now the 4th digit was enabled, unit digit was enabled, and the value is displayed. Unit value of the counter is being displayed there, and now we need to go back to the initial state. We have to disable the unit digit like this. Now for the 10th digit, just copy this. Now display the 10th digit. For the 10th digit, you disable the unit digit and you enable the 10th digit like this. That is at pin number D2, that is digit 3. Now just divide the counter by 10th. Whatever the 10th digit of the counter value is will be displayed here. Again go to the initial state. Now we go for the 100 digit. Copy this again, paste it, and now you simply disable the 10th digit and enable the 100 digit like this, and divide it by 100 like this. And now once the 100 digit of the counter is displayed, again disable the port. Now again go back. Now for the 1000 digit, do the same, disable the 100 digit and enable the 1000 digit. Now this is the 1000 digit and divide it by 1000 to make it a 1000 digit. Now then again you will disable the port. Now before we run the counter, first of all let's check does it work or not. We write a random value like 3758. So this is a random value 3758. So it should be displayed on the screen like it's a constant value. But when we build the code, let's build the code. The code is built. Let's go to the PIC3 programming tool. This is a tool. Okay, I select the file, import file. The file we just this is the file. Click on write. Okay, the file is being written. Let's zoom out and go to the hardware to see what happens. Does it display the digits that we had written here? of 3758. It has to display 3758. Now I turn it on using the PIC3 programming device. So it is displaying 3758, but triggering speed is very fast. You can see that it is displaying the value at a very fast speed. It's a 3758. You can see that. (3758). But we have a bit of blink here. Now that's what I was telling you. You can play with this code. If you simply now let's play with the code. I tell you how you can deal with this. Now we make it go smooth. To make it go smooth, you have to load down the blinking time. To load down the blinking time, that's why I told you this delay is important. You load down the delay. Just make it 5 or just make it 2. I make it 2. I load down the delay to just 2. Now it will have less blinking because we are lowering down the display or delay. This blinking is basically because of the delay, but you have to play with the delay. You cannot make it 0 or other thing. You will not be able to see anything. Now I build the code. I click on write. Let's see what difference it brings, lowering down the delay. Let it write. The new code is being written. See that now it's clear. 3758. You can see it easily on the screen. See. So guys, now you can see it is very smooth. Basically, it's a multiplexing technique. They are being displayed one by one, but our human eye has the ability to see an object. If it goes above the speed of 25 milliseconds, then we cannot see the difference that either it's on, it looks like it's on, but in reality it is just blinking. Now we continue with the coding. Now we make the counter go 0. Initially the counter must be 0, and we add here a command. This counter equals to counter plus 1. That counter increments by 1 after every repetition of the loop. Now we go down and add here a condition that if counter is greater than 9999, we have 4 digits. If it goes above this value, then counter becomes equals to 0. That's all. Now we build this code. Okay, the new code is being built. Let's see. Now the counter must work. You can see that the counter is incrementing. It has now it's the 1000 digit, 100 digit. Now it reached the 1000 digit. You can see the control is being transferred. That is because of that remainder symbol. So guys, you can see our counter is working perfectly fine as it should work. I will give you this all of these MikroC files, hex files, C files, etc. Whatever the files are being generated in the Google Drive link found in the description of this video. You can simply download this code and you can play with the code as much as you want. Now let's see what happens when it reaches 9999 value. Let's see, it is going up 4800. Now it has reached halfway, 5000, 5100, 54, 55, 56. Let's see what happens when it reaches a value of 9999. So it's now at 7000. Now it's at 9000. We are nearly there. It should go back to 0 after hitting 9900. See, it has started all over again. So guys, this is it. Thank you very much for your time. If you have any questions or queries, you can ask in the comment. So I hope you learned something from this video. Thank you very much for your time and patience, and have a nice day, and we'll see you in the next video.